since many years, since decades, I've been working on the problems of mechanical ventilation in people with very severe lung disease, particularly ARDS, and that's what the COVID-19 patients are dying from. And I have been developing a concept based on physics and physiology and a little bit of mathematics in order to define how these patients should be ventilated and also how one should monitor the physiological function of these patients so that you can really know how to ventilate them optimally. And I have been working in this field for 50 years. And I was on my way to publish a rather large essay with all my conclusions in this field. But then came the pandemic. And I realized that it would not influence the society because all these people will be working so hard, so they will have great difficulties to take up new ideas, partly new concepts. So I thought, what can I do in this situation, in this extremely dangerous and severe situation? And I thought about the ventilators. And there are two kinds of ventilators around. One type is intensive care ventilators, which are extremely sophisticated. You can do a lot of things with them. They have all screens, and the screens are crumbled with numbers and curves. They're good for people who really know how to use them. Then there is the other sort of ventilators, which are simple ventilators, often non-invasive, which you apply a mask or nasal prongs, also to connect to the airways. And these simple ventilators, they can help people giving some comfort. But they are not suitable for the very severe cases of ARDS in corona patients. So I thought, wouldn't it be possible to develop a ventilator which is doing all the things, the proper things to treat these patients? Not every patient, but specifically the COVID-19 patients with very severe respiratory distress. And at the same time, be very simple. They should have a screen, but the screen should only show the absolute essential information in terms of some simple curves and a few numbers. They should be very simple to set the ventilator. Few parameters to set, should be strictly logical. So a ventilator which is as all the capacity needed, but still is very simple to use, fast to learn for people who have not long training and developed a high expertise in ventilation. I thought that would be possible, and I must try. And that's what I'm doing now.
But all those ventilators and respirators that we see in the market now, that countries buy 10,000s of, are they completely useless?
These simple ventilators which are being developed now, and politicians and industrialists, they say that we can produce them in tens of thousands. They can provide some comfort to the patient who is fighting for his life. They can also bring comfort to the personnel, the doctors and nurses, because they can do something. And the politicians, they can say, well, see what we have done. Tens of thousands of ventilators are distributed. I have done my job. However, these ventilators are not fit to save the lives of the patients. Bring some comfort, and that's about it. You need to save these patients. The patients must be intubated, have a full narcosis, sedation and narcosis, maybe muscle relaxation also, so that the ventilator can completely take over ventilation. Because otherwise the lung is getting more and more damaged by ventilation itself. Ventilation by the patient or by an improper ventilator. That will rip the lungs apart in different ways. And I know exactly which ways the lungs are being ripped apart. And so my ventilator should avoid this, still be as simple as the low-grade ventilators to use and to learn.
You have a long life experience in ventilators.
Yes, it started in about 1965. I was working together with an associate professor, Sven Ingelstedt, at the ENT department in developing means to study lungs, to study physiology of lungs. He had a pamphlet in his bookshelf, and on the back it said, "God and I know." And so I said to Sven, "Well, God and you, couldn't we be three?" "Well, as time goes by, as time goes by," said Sven. It was not much more than a week later. I found this pamphlet on my desk, and I read, and nearly everything stayed between God and Sven because I didn't understand exactly what he meant. But on one page he said, ventilators are flow or pressure controlled or volume controlled. That is silly. They should be flow controlled. Why? Well, then you could do anything you want. PS, postscriptum. You can't control flow. But I was taken in by this idea, and I said to Sven, but if I develop a flow controller, couldn't we make a ventilator along these ideas? Well, yes, of course you can. So soon I understood that these days flow controllers, why they didn't function as well as they must to be in a ventilator. And I started to think about how they should be. Started to construct flow controllers, but I had to learn. I had to learn how to use a mill and a lathe, and I found a wonderful person at the mechanical workshop at the hospital, Lennart Holst, and he gave me an hour or two showing how these machines worked. I was even allowed to use them in the weekends when the workshop was empty. And I also needed to work on glass, because the flow controller had parts of glass inside. And I met another great man, Alf Lundberg, at the Chemical Center of Lund. He was a glass blower. And he also offered me some knowledge about how to, not to blow glass, but to cut and mill and drill in glass. One day, on Saturday, I was in the mechanical workshop using the mill, and I was polishing a plexiglass cylinder at very high speed. And then I stopped the mill, and the chuck, we call it, the rotating tool holder, the workpiece holder, and it continued to rotate, and it got loose, and it weighs about 6-7 kilos, and it danced all around the room, and I took shelter behind the lathe. I was thrown out of the workshop, of course. I had been working alone, but there were traces about a little bit everywhere, so I couldn't hide what had happened. Today you would never be allowed to work alone in a workshop. So, at the end, I found a solution how to have a very good flow controller. Mechanical one, no electronics. And I started to build a ventilator. I found an engineer. There were no hospital engineers in these days. But there was a man who was selling ECG machines and bicycles, exercise bicycles, ergometers, to the Department of Clinical Physiology where I was working. And I said, you must create some electronics to open and close my flow regulators, to start and stop inspirations and expirations. And so he did. And within a very short period of time, we had a small ventilator, about 3.5 kilo, that could do everything an Engström ventilator in these days could do, and much, much more. It could, for example, follow the to some extent follow the breaths of the patient. I wrote a patent and left it to a patent bureau, and they said this is not possible. Then I said, okay, I will do it myself, and then I sent in the patent. That was on a Monday in August 1967. On Tuesday, the following day, I visited Siemens Lilla in Stockholm. And there I met 3 great men. Weber, who was the chairman of Siemens Lilla. Börje Rudewald, who was the CEO. And Dr. Kurt from München, a very impressive German man. Impressive in every sense. And on a pedestal I put my little ventilator, and I connected it to the compressed air, to electricity, and ventilated the balloon. And I showed to them that I could do a great job with this small machine. They were immediately taken in by the idea. And I left the patent, which has been sent in the day before. In the coming days, we had some telephone conversations, and 8 days after the patent application, we signed an agreement that Siemens Lilla, the name was Lilla Schenander in these days, but it was already owned by Siemens. We had all the freedom, and we got all the resources needed to develop the ventilator. We could use our own staff, own patent bureaus, own designers, etc., because we didn't want to be tied down by the heavy German-influenced organization. Complete freedom, adequate resources. We created a great team in Stockholm. and started to work, our ambitions increased. And my flow regulators, we thought they should be completely electronic. So we constructed electronic flow controllers. We constructed flow meters. There were no electronic flow meters available in these days. There was not even a pressure transducer. So we had to do everything ourselves. And that started in early 1968. In 1970, the first prototype of Servo Ventilator 900 was operative and used in animal experiments. In 1971, after just 3 years, we had the Servo ventilator on the Scandinavian market to start with. There were no regulating rules in these days. When the ventilator was available in prototype in the summer 1970, I brought one to Hässleholm, a small town in the north of Skåne, where I was working as a surgeon. As a training to be a licensed doctor, I had to do some surgery. And I brought the ventilator there, and I also ventilated a few patients, among the first ones. It created a revolution. It was small, about 10 kilos. The Engström ventilator weighed about 180 kilos. The Servo ventilator was silent. And that was a little bit of a problem, because the staff was used to that the ventilator should say whoosh, 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 and it stood there and ventilated the patient without a sound. They couldn't see a movement. So they thought, they were a little bit afraid that it didn't work. But it worked, of course. It not only ventilated the patient. I was a physiologist. I was a clinical physiologist. So it was a monitoring machine. So it followed the pressure, it measured pressure, it measured flow rate, it transformed flow rate to volumes, to tidal volumes, to minute ventilation. And these could be monitored, the pressures and the ventilation, and alarms were issued when something wasn't correct. That was another problem, because the staff were not used to alarms. Something like PEEP, PEEP, PEEP. They were disturbed to start with, and we had to really go through training, say that this is good for you, that you can relax, and as long as it doesn't say PEEP, 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 everything is okay. These were the days in 1971.
Many open doors, it sounds like. More easy access.
Yeah.
As you have expressed.
We worked under complete freedom. Adequate economic resources. Could pick our people. Very young people. Most of these people came directly from the technical high school in Stockholm or other places. And we trained them in the medical field and in the physiological field, expressed what we needed, and they solved the problems. It was a miraculous time, and it created a miracle. The Servo ventilator was a miracle in these days. I am proud to say that. I have never said these words before, but now I dare to do it.
It's amazing. So, if we are here today now, with your work you do today, what challenges do you meet?
I meet great challenges. I have been working in research, in intensive care for all these years, and I still do to some extent. And I have worked out, together with other great scientists in Germany, France, nowadays in Canada, concepts which I believe could infer much better ventilation that is offered by today's ventilators. The trend today, or for decades, has to be to find simplistic solutions to every problem. And simplistic means that you look at one single factor at a time, like PEEP, positive end expiratory pressure. That's a jewel in the research of ARDS. Positive end expiratory pressure means that the pressure is maintained positive in the airways throughout expiration. So, and that the purpose is to keep the lung open, because the lung has a tendency to collapse during expiration. And if you apply PEEP, they should not be allowed to collapse. Because collapse and reopening, that's the most destructive factor which creates ventilation-induced lung injury. And there's been hundreds, probably thousands of articles about how to titrate PEEP, how to find the proper value of PEEP. That is simplistic. I would say it's stupid, because there is no optimal PEEP. You must combine PEEP with a particular tidal volume, with a particular respiratory rate, with a particular flow pattern during inspiration. All these factors must come together to create an optimal. But then you come to evidence-based medicine, which is another problem. If you want to have evidence, you must show that one factor should be controlled in this or that way. PEEP, for example. But there is no optimal PEEP. If you don't take tidal volume into account, respiratory rate, etc., all these factors. So evidence-based medicine is one problem. And to test these simplistic ideas, people create enormous multi-center studies. Thousands of patients are engaged. And what comes out in more than 9 cases out of 10, that it did not make any difference if you had high or low PEEP, small or large tidal volumes. There's one study that shows that low tidal volumes is better than high tidal volumes. So and that's good evidence. We have good evidence for that. But for the rest, the evidence is missing. And that's the challenge. And my concept is built on to have a unified model based on physics, physiology, to some extent mathematics. How should you ventilate these lungs to allow proper gas exchange? But as important, it is to prevent ventilation-induced lung injury. Those two must come together. And you can only do it by combining all these different settings of the ventilator. And that's in my...
What do you need now? How far is this ventilator to the market?
The one I'm working on?
now, yes.
Well, I've been working for the last about 6-7 weeks with a big Swedish company with a conceptual development. And we are ready with the concept. And we have shown that it is possible to build such a ventilator. It is possible to build it at a price which is much, much lower than the price for intensive care ventilators in general. But this company, they are not selling. They have no sales organization. So we are a little bit stuck at the moment because we need people who are ready to invest. And we have to identify companies who are willing to accept the risk to put this on the market. Because it's a difficult market and there are risks involved. Even if this ventilator would be very good, very efficient, there are large obstacles. Regulations, for example. You must have these accepted by authorities. And for COVID-19, you could probably solve the last for a temporary allowance to sell it. But you need something more for the investors. So what is needed is, what I say, true industrialists, like the people I met in 1967, who are saying, we take the risk, here you have the resources, and if you are successful, we will sell it and bring it to the market. I have said my trip was pretty easy. I was lucky. I met the wonderful people, the right people. I got the idea from Sven. And then I started it all. Today it's more difficult. But believe me, it will always be possible. There are these wonderful people around. You must find them. You have the idea, you must, nothing should stop you. Work on your ideas, make them clear, find the proper people, show them, catch them, and do it.